So we're looking at this answer, which is almost done. One more in here. Looking at this answer now in the truest format of Jeopardy, your question would have to be, I think Brandon, you started it correctly. The question would be, what is the derivative of, and then you'd fill in the blank, correct? Okay, so let's see. Let's let Kim's pushing buttons there, so we'll let her finish here. And as we're waiting, are you thinking, why did the rule I know work? Or if you don't know the rule, could you tell me what you were thinking? Okay, so let's see what we've got here as answers. Okay, obviously some people know what they're doing because someone has a plus C on it. If you were not in another class, you might not have thought of that, but let's see. If we're looking at what is the derivative of x squared plus 3x, would your answer be 2x plus 3? Okay, now, x squared plus 3x, x squared plus 3x, did anyone give me something other than that? X squared plus 3y. Ooh, where'd that y come in at? Is that a slip of a typo? Is that just a typo there? X squared plus 3x, x squared plus 3x. Oh, x plus 3x squared. Let's think about that just a moment. If I took the derivative of this, derivative of x would be 1. Derivative of 3x squared would be 6x, so we wouldn't get the same thing. So if that was yours, what is the derivative of x squared plus 3? I agree, x squared would give me 2x, but 3 would give me 0, okay? And then a no idea. Okay, being the first one, the first time we ever looked at these, I would agree. Now, there was truly only one correct answer, and that would be the two people who gave me this one. Why would those be more correct? Yeah, Emma? So we could put anything on any of the rest of these, any constant, and the derivative of that's going to be 0. Now, I agree with our answers. Okay, so we'll save those to the portfolio. And before we get thinking about this, again, the better question would be, what is the derivative of? How did you process that? I don't want to hear from someone who used a rule. I want to hear from someone who doesn't know a rule. How did you process this? No wrong answers here, okay? Or are you telling me that everyone in here knows the rule? Okay, okay. Who's never had this before? Okay, Hannah, how did you get? Was one of those correct ones yours? No. That's okay. That's okay. Don't. I won't fuss on that right now. Okay. How did you process to get x squared, for instance? Okay, so you reverse the order of operations needed to take the derivative. Okay, so instead of multiplying times with this, you remembered that if you multiply, you got 2x, so you would need to, instead of multiply times 2x, you might want to somehow, okay? I'm not sure what we would call that process, to take a coefficient and make it an exponent. I don't think we even have a name for that. So as far as reversing the order of operations, we have to kind of think a little bit more, but her idea is correct. How'd you process the 3 then? Okay, so it's more of just saying, okay, what would create a 2x if I won? Okay, anyone have another thought process? There's no wrong answers here. Hannah, did you? Same thing? Okay. Now, I started erasing because Jenna mentioned an order of operations, although it is a little bit, it's hard to, to imagine that if you're going to, if here you multiply 2 to the coefficient, that somehow you take the coefficient and make it an exponent. That's not really a reverse operation there. But we are going to do a reverse of order of operations and a reverse, or let me put it this way, and we're going to use the opposite operation. So the order in which you do things is in reverse, and the operation we use is going to be its opposite. So if I add, I would subtract. If I multiply, I would divide, and so forth. Okay, so kind of keep that in mind. Without asking you, giving you any more hints, let's do another one. And I'll get this up on the, what am I trying to say? In the navigator, the quick poll here in just a minute. So here's the next one. That's a 7. That's a 7. Let's talk about what is our process for finding the derivative. Can you put it into words, the process? The first thing you do is, yeah, Emma?
Times the coefficient of 1 times the exponent.
Okay, so the process, the first thing is to multiply the exponent with the coefficient. Okay, what's the second thing you do? Okay, so subtract 1 from the exponent. Okay, let's see, do we have everyone now? Okay, good. Let's take a look at these. Right. There we go. Okay. Okay, so we've got 1/3 x to the 7th. So if I take the coefficient times, or the exponent times the coefficient, do I get 7/3? Yes. Subtract 1, do I get x to the 6th? Okay. This says plus e to the x, or plus e to the opposite of x. Would that give me negative e to the x? Because when you take the derivative of e to a power, the first thing you do is write it exactly like it is, which would be e to the negative x, and we'd have that, if this is negative x here, then this is a composite function. Good try, but not exactly. 1/3 x to the 7th minus e to the x plus c. Okay, so we agree 1/3 x to the 7th yields 7/3 x to the 6th as a derivative. Minus e to the x, the derivative of that would be minus e to the x plus c. And do we have any others? There's another one like that. Now, what's the difference between these two? Why didn't the Inspire count them as the same? Did you look at your Inspires? Do you see that you have a special character E? If you use the alpha key for E, it does not recognize it as the number, the value E. And how do I know which one of these is using the proper E? It's if in bold. Yeah, it's a reserved name. So on the gray one, I think there's a key that has E on it. Actually, it's e to the x. Okay, I think on the touch screen it also has the e to the x. Okay, so make sure you, if you're going to compute with that, make sure you do that. Okay, so we got a lot of people who have that part right, and now I don't know why it didn't count these two correctly. Oh, because we have there's two different kinds of C's here too. Interesting. I'm not sure, I never noticed that before. Okay, but if we have 1/3 x to the 7th minus e to the x plus c, we should be okay with that. Okay, we'll update the portfolio. Okay. Now, let's go back and let's look at this. On the first one, the order in which to take the derivative is, as we said, we multiply the exponent with the coefficient, and the second thing we do is we subtract 1 from the exponent. What are we actually creating with this little Jeopardy game? I guess I can't really say that. Okay. I was going to say an inverse function, but that's not really absolutely true, because an inverse function does what? Solves for the unknown, solves for the input variable, and we're not really solving for the input variable in this case. But we are doing this this reversal. Okay, so if we're going to reverse everything, you know, over here, if this is number 1 over here, and this is number 2 to find the derivative, which one am I going to start with? Reverse the order of operations. My order is important here, right? Well, you could argue, I guess, differently, but if I subtract 1 first and then multiply, I do get a different answer. So, my order is important. The second thing I do becomes the first thing over here. But you also use the opposite of the operation. So instead of subtracting 1 from the exponent, what are we going to do? Add. Add 1 to the exponent. Now if this has an exponent of 1 and I add 1 to it, what do I get? 2. Okay, so the second thing that I do was really the first thing over here on the derivative side. So the second thing, here I multiply the exponent with the coefficient. Instead of multiply, I'm going to divide by the new exponent, because now the exponent is 1 more than it was before. So I'm going to divide by the new exponent. So what I end up with is I would add 1. So if I take 2x plus 3 and I do this, I would add 1 and I would subtract by, so that's 1 plus 1, subtract by the new exponent. And do I get x squared? Yeah. 3 is the same thing as 3x to the 0. If I add 1 and then divide by the new exponent, do I get 3x? And the answer is yes. So we're going to reverse the order and then use the opposite of that. Does it work down here for this one? Let's see. If I have 7/3 x to the 6th, if I add 1, that makes it x to the 7th. If I divide by 7, that's the same thing as multiplying by its reciprocal. Do I get 1/3 x to the 7th? Yeah. What happens to e to the x? Well, e to the x, it kind of plays by its own game. So it would be minus, there we go, e to the x. And again, we need to add plus c. So I'm going to go back up here and put the plus c on that. Okay, so there's the rule. Now, of course, I can always mix it up a little bit. And so here is your second one, or your third one. dy dx equals secant x times tangent x. Now this becomes a little more difficult now. Now we have to go back and remember what function would give